All right, so here we are, section 11.2, part 2, our last section, our last page, our last test. In this section, we are going to take a look at what's called the chi-squared test for homogeneity. Basically, what's going to be tested here is we're testing the claim that different populations have the same proportion of some characteristic. Right? In a typical test for independence, the sample subjects, everybody's from the same population. In this one, in the test for homogeneity, we are going to assume that we have two different populations measured against the same variable, and we want to see if the results are the same or if the results are different. If they're the same, then the test for homogeneity would say that the two populations have the same proportion for those characteristics. And if they're different, we would say the two populations are different. Right? So you could say, hey, do online students and in-person students get the same grades? So then one population would be online students. A second population would be the in-person students. We would compare the A's, B's, C's, D's, F's, W's for the online students with the same characteristics, the A's, B's, C's, D's, F's, W's for the in-person. And we'd say, hey, if they're the same, then while these are two different populations, they measure the same on this measurement, that is the grading. And if those groups were different, well, we'd say they're different populations and they have a different relationship with those variables, essentially. Right? The good thing about this is that all of the work that we do here is the same as what we did for the last section for independence. We use the same notation, O's and E's. We use the same requirements, that it has to be random, that we have to have random data organized in a table, and that we have to have at least 5 in the expecteds. But instead of testing a null hypothesis of independence between rows and columns, we are going to test the null hypothesis that the different populations have the same proportions. So the null will say the proportions are the same. The alternate will say that the proportions are different. Right? So here's our first example, our only example, favorite movies. You randomly select 500 college freshmen. 200 are men and 300 are women. So there's one population. There's our other population, men and women. Okay? We measure them on the same thing. We say, which of the following movies do you like best? The Batman, Everything Everywhere All at Once, or the Lego Movie? We get the results, we put it into a contingency table, and we want to test whether or not these proportions are the same between these two populations, or these proportions are different between these two populations. That is, when I look at this table, this 150 out of 300, is that the same as 95 out of 200? Is 110 out of 300 the same as 75 out of 200? Is 40 out of 300 the same as 30 out of 200? All right. So that's what we're going to do. We're going to test that relationship. Okay, well, the good thing is, since this test runs exactly the same as the last one, I can just jump right into it. Okay. All right, so what's our claim? Well, our claim's here. Our claim is that men and women have different movie preferences. That's our claim. So when I set up my null and my alternate, my null is always that they're the same. So that the men and men's and women's preferences are the same. The alternate is that men's and women's preferences are different. All right. Our data is that table, and our alpha level of 0.05 that we're going to test against. All right. I need to take that table and I need to get that table into the calculator, because the test for homogeneity is the same as the test for independence. Boom, 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 make it into a matrix, put it into the calculator. That is a 3x2 matrix. So back to matrix, over to edit. It is now a 3x2 matrix. Okay? 150, 95. 110, 75. 40, 30. Check my data twice, 95, 75, 30, 150, 110, 40. Looks good. Quit out of there. Stat, test, chi-squared test. This time, instead of for independence, it's testing homogeneity. Calculate. I have a chi-squared test statistic of 0.413, but more importantly, I have a p-value of 0.81. When I compare p to alpha, p is greater than alpha. That means that when p is greater than alpha, we fail to reject our null hypothesis. Now, what was the claim? Well, the claim was the alternate. So that's the same as what happened up here, right? The claim was the alternate. Oh, I lost it. Don't ask why. Long story. The claim was the alternate. So then we've got to say, what does that mean? Well, that means that there is not enough evidence to support the claim. I need to move this. That men and women have different preferences. Okay. Well, I don't know about you, but I'm sad. I'm sad because the semester's over. Essentially, we have just a couple things to finish up, a couple homeworks to do, a couple things to move on with, and then we're done. That makes me sad. But I hope you enjoyed the semester as much as you can enjoy any math class. I know that I really appreciate this, and I appreciate those of you that have worked hard all semester long. I know, given a late start class, that this is fast-paced, and I appreciate what you've done. I look forward to seeing you all finish that final, do well on that final, and have overall success in this course. Have a great day.